and thank you, Natalie, and we'll continue and start the second part of our Green Chemistry Connections today. So we heard from Edson Grandidoli. He had to leave, but he left his contact, so I can put in the chat too. If you have any questions, you can reach out to him. We heard from UNESCO, our GCCSigners, and the green chemistry that's happening over there. And now we're going to continue with the Latinx Chem presentations, and we're going to hear from the University of Pelotas. So we'll have Sabrina and Gabriela presenting today. So you have our contact, our GCC contact in University of Pelotas is Ede. He's here in the chat. So please, Ede, again, sorry, I'm putting you on the spot here, but please feel free to reach out to Ede if you want to know more about the Greek commitment in University of Pelotas. And we have Sabrina. Sabrina, she's going to talk about the WWVerde, which is the Green Chemistry Propagation page of Green Chemistry in Brazil. Sabrina, she's an undergraduate student of Industrial Chemistry at Pelotas since 2020. She was a fellow of the extension project WWVerde, the page for dissemination of green chemistry in Brazil, and she's currently a volunteer on it. She participates in the development of organic synthesis research at the Laboratory of Clean Organic Synthesis under the supervision of Ede. And Gabriela, she's going to talk about some really cool organic chemistry, as you can see from the title. She's an undergrad of industrial chemistry at the University of Pelotas since 2019. She's also a volunteer of the extension project WWVerde, the page for dissemination of green chemistry in Brazil. She's a fellow of scientific initiation, development of organic synthesis research at the Laboratory of Clean Organic Synthesis, also under the supervision of Ede, Professor Ede João Leonardão. So I'm going to invite Sabrina. I can see her already. I have her poster here, actually. I'm not going to invite her to share her screen. So Sabrina, the floor is yours. Please tell us what WWVerde does.
Thank you for the introduction. Hello, everyone. My name is Sabrina. I am a graduate student in industrial chemistry at the UFPel. I will present the project entitled WWVerde, the page for propagation of green chemistry in Brazil. A milestone in the propagation of green chemistry around the world was the release in 1998 of the book Green Chemistry Theory and Practice by John Arne and Paul Anastas. 24 years after the publication of this book, the availability of material in Portuguese on the subject is still limited. WWVerde, verde meaning green in Portuguese, was created 20 years ago by a group of professors from the Federal University of Pelotas, with the intention of being an interactive internet page providing educational resources and scientific articles translated in Portuguese. In addition to Brazil and Portugal, Angola, Mozambique, Cabo Verde, Guiné-Bissau, Equatorial Guiné, São Tomé and Príncipe, and East Timor also totaling about 300 million people. Therefore, the availability of quality resources on green chemistry in Portuguese is very important, which is population. It is mentioned the WWVerde project was initially only present in the form of a website. In 2014, WWVerde underwent improvement to a WordPress type version and became available on the social platforms Facebook and Twitter. In 2020, an Instagram account was created, allowing searching for platforms. Increase the visibility of green chemistry in Brazil and other Portuguese-speaking countries. The published content is obtained from reliable and quality sources. Shared with the population, it contributes to raise awareness and encouraging the use of greener alternatives in the multi-diverse way of production and consumption. WWVerde is maintained thanks to the voluntary works of 2 students from the industrial chemistry course at the UFPel, Miss Sabrina and my colleague Gabriela, under the supervision of Professor Ede João Leonardão. The teams meet weekly to discuss the content to be published. The search for news is done in in scientific journal. They published in Green Chemistry, New Science, and publications on Twitter and other platforms. The team chosen for publications is viewed a summary is made, which attractive images stage were posted in WWVerde platforms. The goals of WWVerde were which aims to encourage the use of green alternatives, make society aware of the impact of human activity, warn about environmental issues. WWVerde future goals increasing the reach of publications, promote interactive content, create an interactive map demonstrating where NGO is doing green chemistry in Brazil, create a podcast. We can therefore conclude that WWVerde generates access to informative and quality content in Portuguese about green chemistry and facilitates the dissemination of science. Thank you very much.
Thank you so much, Sabrina. I forgot to start my video, but I just want to highlight how important this work is. And I've been following you on your social medias for a while now. And this actually, like, you're actually doing a wonderful job in educating people about green chemistry and showing what green chemistry is in Brazil. And I wish I could have this opportunity when I was there. So here's an invite for you to follow WWVerde, which Verde means green in Portuguese. So it's a great initiative, and I'm really proud. I'm really happy to work with you on this. So I'm gonna ask if anyone has any questions for Sabrina. We have a lot of congratulations in the chat for you. Yes. Okay. Yeah, so everybody's saying thank you and congratulations. And actually, Sabrina, thank you and congratulations again. And please follow WWVerde on the social media because they do a really good job. And if you have any Portuguese speaking friends, please tell them about this initiative. So thank you so much, Sabrina, for showing us this amazing initiative. Awesome. I'm gonna invite now Gabriela. Are you in the line, Gabriela?
Hello, can you hear me?
Yes, I cannot. Okay, awesome. So, Gabriela, this is your poster, your amazing poster. So please tell us everything about this amazing green chemistry research in Brazil.
Yes. Hello, everyone. My name is Gabriela, and I'm in the third year of industrial chemistry course at Federal University of Pelotas, and my supervisor is Professor Éder Lenardão. And today I will present a summary of my work that I'm developing at Laboratory of Clean Organic Synthesis, LASOL. The title is Arylseleninic Acids Selenylation Agent, Photocatalytic Synthesis of 3 selenyl indoles under blue LED irradiation. So the indole core is has privileged structure due to its ability to bind many receptors. Moreover, it is an important part in the many drugs, having several properties, such as anti-inflammatory, anti-neoplastic, and anti-headache ones. For instance, the alpha-amino acid tryptophan and the neurotransmitter serotonin are indole derivatives. On the other hand, organoselenium compounds are known to have pharmacological properties, such as antidepressant and anti-Alzheimer. The objective of my work is to obtain 3 substituted selenyl indoles under photocatalytic conditions without using transition metal, catalysis, strong acids, or high temperatures. This green procedure uses arylseleninic acids as an alternative selenylating agent. Besides being stable and presenting low toxicity, the only co-product of the reaction is water, environmentally benign waste. To obtain the optimal reaction conditions, we tested different solvents, photocatalysts, LEDs of different power and color, and the reaction time was also investigated. After preliminary studies, the optimal reaction conditions were found using Y has photocatalyst, 5 more%. The MSO has solvent under irradiation of blue lead, 50 watts for 1 hour. It was found at entry 1. Therefore, based on the optimized reaction condition, we have performed the reaction scope. Different arylselenic acids were investigated. Arylselenic acids containing electron withdrawing groups, arylselenic acids with electron donation groups, and also halogen substituted ones were tested. Till now, the protocol was used to prepare 7,3-selenylindole in 30-70% yield. This work is still in progress. Thank you so much for your kind attention.
Thank you so much, Gabriela. I'm really slow to start my. Thank you so much, Gabriela, for your presentation and for your work. It's really exciting. I really remember seeing your poster. I love the color, so I put the pink thing in the background. So everyone, do you have questions for Gabriela? Please feel free to unmute yourself. We have a lot of congratulations in the chat. I do have a question, Gabriela. I don't know if it's really stupid. I see that you used white LED lights and blue. Is it because of the frequency? Like, can you try more different LED lights? What is the reason of the specific blue LED irradiation?
Yes, we tested different colors because of the, I don't know, comprimento de onda.
Wavelength, yes.
Yes. Sorry. Yes, and it's the reason.
Yeah, awesome. Thank you so much, Gabriela, for everything, for amazing presentation. And I'm gonna move over to our next speakers. Dun, dun, dun. So we're moving the green chemistry commitment signers now. We're going all the way to Duque de Caxias in Rio de Janeiro, in the state Rio de Janeiro. So our GCC signer contact over there is Kelly. So if you have any questions about how the commitment's going at this university, please feel free to reach out to Kelly. Also, we'll have two different presentations. We have three presentations actually. So the first one is from Maria Victória. She's gonna talk to us about a game for teaching green chemistry, which is super cool. So Maria Victória, she joined the chemistry program at IFRJ in 2018. As an undergraduate, she participated in some projects that insert undergraduate students in public high schools to develop new education methodologies, elaborating materials, experiments about green chemistry and sustainability, and promote feminine participation in science, which is amazing. She volunteered in a project about chemistry experiments, producing videos for YouTube as well. And recently, Maria Victória created the Green City, this educational board game produced to promote green chemistry and sustainability in school, which is amazing. We're also going to hear from José Victor Lopes about the green chemistry analysis of biodiesel using ultrasound. José Victor, he is a chemistry undergraduate, and he has a technical medium level in teacher training. He was a volunteer in the Supramolecular Chemistry, Nanoscience, and Nanotechnology Tutorial Education Program, and he has received a scholarship from CAPES for the Institutional Scholarship Program for Teaching Initiation. He's a fellow of the Institutional Scientific Initiation Program at the IFRJ campus, with emphasis on the application of holistic metrics of green chemistry in chemical experiments. And he's also an intern in a project in partnership with ECNOR in the macromolecules and colloids fields in the petroleum industry. And we have our two speakers, which also are going to talk about more about the dissemination of green chemistry in Brazil, which is amazing. We'll have Larissa and Thalia. So Larissa, she's an undergraduate at the IFRJ, and she has an intermediate technical level in chemistry. She was a scholarship holder by CAPES for the Institutional Scholarship Program between the 2020 and 2021. She's a fellow of the Institutional Scientific Initiation Program at the IFRJ campus in the area of green chemistry. And Thalia, who is in the line, who's in the call meeting, she is a graduate student and at this institute, and she was a CAPIS scholarship holder between 2021, 2022, 2020, 2021, and 2022. And she is a scientific initiation scholarship holder in the project of assessment of suitability of water-soluble polymers for use in aqueous drilling fluids in partnership with Petrobras, which is a big company in Brazil. Okay, so everyone, I'm gonna move to Maria Victoria. I see her over here to present her poster about the Green Chemistry City, the Green City game for teaching green chemistry. You can follow her poster along in the chat that Nim is gonna put the link. So Maria Victoria, the floor is all yours.
Hi everyone, Juliana. My friend will set up the presentation for me. Can he?
Sorry?
Can he set up the presentation for me?
Oh yes, sure.
Because I prepared some slides, but I forgot to send her a mail. So
no
sorry.
worries. I'm gonna stop sharing my screen so you can do it.
Thank you so much. Because my computer just zoomed out and he's just going to present for me.
Go, José Victor.
Ooh. Okay, so let's go. Good afternoon, everyone. I'm Maria Victoria Barros Costa. I'm a student from Federal Institute of Rio de Janeiro, and I'm going to present my work entitled as Green City, a game for teaching green chemistry. If you had any questions about the work, please let me know in the chat and I will happily answer them. Okay. Pode passar. Thank you. So green chemistry, it's gaining space in scientific and environmental events, but when it comes to scholar approach, it's quite invisible for teachers and students. Okay, so knowing the importance of introducing green chemistry in high schools, we create a board game to make the approach easier, connecting sustainability, which is a pretty common topic in high schools, and green chemistry, a non-obligatory one, at least here in Brazil. So the board game was created with a contest, entire contest, to help the players get to know green chemistry and sustainability in a daily basis form. So we named the board game as Green City, as you can see in your right side, reflecting the game's main goal, which is building a greener city. And we decided to turn every single action present into the game to that scenario. Oh, okay, thank you. The game was created for teachers to amplify green chemistry voice in high schools. So the minimum players number is 9, making the application easier facing the big classrooms that we have here in Brazil. Sometimes here in Brazil, we have 45 students in a classroom, so it's a really big number, and we wanted the game to involve all the class, so that's it. The players are separated in groups with an equal number of players, and each group elects one player to represent them during the game. But it doesn't mean that the elected one will be played just by himself, no. The player depends on the group to take some actions during whole the game. So it's all about teamwork. The group declared as the winner needs to pass goal line and collect at least 3 green chemistry principles. I'm going to show the cards in the next slide, please. Just swipe. Next slide, please. Thank you so much. These are the cards. They have to collect at least 3 green chemistry principle cards during the game to win. So you don't have just to cross the final line. No, you need to collect them during the game, and it's pretty easy to get to know them. It's some situations it's for luck. Some situations you get them by answering the correct answer. So it's pretty easy actually. But firstly, Green City was supposed to be a website. But when we thought about schools with available internet, we thought it wouldn't be pretty good because here in Brazil we have some really problems with connecting stuff. So the game was a please. You can slide to the next one. Thank you so much. The game was applied to classrooms in 4 and 6 semesters in the technical chemical high schools from Federal Institute of Rio de Janeiro, and we obtained pretty good results about application. Pode passar. We obtained pretty good results about application. As you can see the photo, they're playing the game. You can see the board, the dice, the cards, and some stuff that we built for the game, actually. And they were really excited about the dynamic of the game. And we as creators were real pleased with the feedback that we gained with the game. So we, creators of Green City, thanks Biombinai, Verde Lab, and Federal Institute of Rio de Janeiro supporting the presentation. If you had any questions, please let me know. And that's basically it. Thank you so much.
Thank you so much, Maria Victoria. This is amazing. I love to actually see the game. Like I felt Jumanji vibes.
Thank you so much.
No,
I love it too.
Really, like, can we have this? Can we sell this? Like, how can we, are you planning to do something like this?
Yeah, constructing the game was really hard, but we are working here on the, I don't know how to say in English, but patentear.
Yes, a patent, yeah.
Yeah, we're working on it right now. It's quite confusing to me because I've never done something like that before. And when we create a game, it was really simple. But when we get into it and just turns out like this, for me, it was a really incredible and amazing experience to create that. And I'm really excited. And maybe we can sell, I don't know if you want to. We can figure it out something about it.
No, this is amazing, Maria. Honestly, I love the idea. I love to have a game about this. I feel like it's easier to learn things, especially in high school, whenever you're having fun with them. So thank you so much. Do you guys have any questions for Maria Victoria and the Green City game? Yeah, everybody's saying they love it. Yes.
Oh, thank you so much.
We have a lot of things in the chat. But do you have any questions about creating a green chemistry game for Maria Victoria? She's already doing a patent, so. Okay, so you can check out her poster. Nim just put the link in the chat, so you can feel free to reach out to Maria too to ask her about her game. And thank you so much, Maria Victoria. This is amazing. And for presenting your game to us as well. This is awesome. Okay, thank you so much. Oh, we have a question, Maria Victoria, from Eder. Sorry. Okay. He's asking how long the game is.
Oh, we have a quick version because we know how classrooms can be so messy. So the quick version is more like 30 or 20 minutes, depends on the players. But we have a long and the full version actually of the game, 1 hour max. Yeah, 1 hour. And we can, enjoy all the games and all the cards and everything would be really dynamic. And that's kind of it.
Awesome, Maria Victoria. Thank you so much. Yeah, and Conrad said it's a great concept in making a game about green chemistry. So thank you so much. I'm gonna turn over to Larissa and Thalia if they are there.
Hi, I'm here. Hi, I will share. Hi.
So would you like me to? Oh, you share? Okay, thank you.
Thank you.
Okay, so Thalia and Larissa, they're going to talk about the use of social media to also promote green chemistry and sustainability in Brazil, about in their page Verde Lab of the IFRJ.
Hi, thank you, Ju. And hi, everyone. Good afternoon. As Juliana said, I am Thalia Ayane, and I am 22 years old. I'm from Duque de Caxias, in the state of Rio de Janeiro, Brazil. And I'm a graduate student at the Federal Institute of Rio de Janeiro, studying a degree in chemistry. And today I'm here to talk a little about our project. And before we talk about the project itself, I would like to introduce my project partner, Larissa Nogueira. We worked together on this project and share some functions. and in order to achieve our goal. And we are part of Verde Lab, a sustainable laboratory at our university, which believes in the dissemination of green chemistry practice in basic and higher education. And in this way, seeking to democratize access to scientific information and encourage discussions and pay attention to the impact of technological aspects that change the world, resulted in the idea of promoting the dissemination of green chemistry through the use of digital media. So, disseminating how environmental technologies and sustainable development are helping to reduce the damage caused by pollution actions on the planet. So, the purpose of this work is to identify experience, problem social environmental research, and studies in the area of green chemistry and provide society with these contents through digital media, thus expanding their potential for understanding, accessing, and popularizing these scientific contents, promoting change in behavior necessary for achieving a more sustainable future. So, initially, the profile on the Instagram platform was created in May 2021 as an educational profile, and next contents based on various materials from reliable sources such as books, scientific articles, article publishers in newspapers and magazines were selected so that posts with an educational or informational network could be created. And as a result, we can observe through the metrics provided by Instagram itself that our audience is mostly female, 72.8%, portraying the increased role of women both in society and the scientific field today. And we can see too there is a diversity regarding the age group of the followers in a satisfactory way. In addition, we achieved a 16.5% growth in reach compared to the previous month. So there is great interaction with IFRJ members and also members of external communities, includes professionals from other educational institutes and something like that. And in addition, it was through our profile and our job that we received an invitation to be uh, the first signatory in Rio de Janeiro of the Green Chemistry Commitment created by BNI, thus showing how much our reach has increased and reached a different audience. So it's a pleasure for us. And in view of this, the use of social networks by educational institutions has been consolidating in the educational field, and the content production is enriching, contributing with initiatives to transpose content beyond the traditional classroom and encourage to the active participation of students involved in the teaching and learning process. So the construction of scientific knowledge is only possible due to the dissemination and discussion of its results. So I want to thank IFRJ, my teachers, my team partners, and all of you for this opportunity and attention. And feel free to follow, accompany, and share our Instagram, VerdeLab_IFRJ. And I will try to send the link here in the chat, but it's that. Thank you so much.
Thank you so much, Thalia. I just saw that in the Instagram, they posted some beautiful infographics about the green chemistry commitment, explaining what it is. And it's amazing to have this dissemination of green chemistry in Brazil. I think, as I said, this is a very important work that you all do, and we're really excited. Do you have any questions for Thalia about the social media to spread green chemistry in Brazil? I do have one question, Thalia, if you don't mind. So I know that you're very active on Instagram. I mean, I think have you ever tried different social medias? Like, have you tried Twitter, Facebook, to do the same thing? And would you expect the result to be different in that sense?
Well, one of our wishes is to be able to expand our way of disseminate content, because currently we are a little limited only to textual publication. So we want to produce videos and lives with some partners in the area, develop a website. So currently the project is focused exclusively on Instagram, but we are analyzing other alternatives like TikTok, Twitter, and YouTube to spread the reliable information.
Awesome, Thalia. Thank you so much. And when you do create TikToks and all of the different social media, please let us know. Yes, I'm not a TikTok person, but I'll follow you and then see what you're doing.
Okay. Thank you so much.
Everybody's saying good work, Thalia. It's amazing.
Thank you.
So I'm gonna turn over now to José Victor. Oh, I see you, José Victor. Thank you so much. Are you going to present your should I put my slides? Do you have your slides?
The Thalia is the presentation.
Okay.
Thanks.
Awesome. So José Victor, the floor is yours.
Good morning, good afternoon, good evening, wherever you in the world. And today I will talk about gene chemistry, analysis bioelastic metrics of biodiesel synthesis using ultrasound. This work was supervised by Professor Dr. Tiago Mozavessa and Dr. Kelly Aparecida de Almeida. Initially, we have to consider that society has been continually considered with environment cause. With this in mind, gene chemistry emerged was a potential area to study initiatives and the new ways to obtain materials with more sustainable, generate great contribution to industry and research. So biodiesel emerges as a source of energy capable of reducing the impact that this exploration active has on the planet. In Brazil, in 2021, it is estimated that the product at around 13.8 million reals, which gives approximately 2% of gross domestic product on the country. For this reason, the objective was proposing an alternative synthetic route for the biodiesel, considering its power to replace fossil. In the addition to that, for this measurement, the holistic method of gene chemistry was used in order to evaluate each variable. The experimental procedure estimate the effect of change in ecosystem terms. The methodology of the work was based in the reaction transesterification, which a reaction of triglycerides with an alcohol and the presence of the basic or an acid catalyst. Traditionally, the science used oil source, methanol, and catalysts such and sulfuric acid. The experimental procedure commonly reported on the literature were changed. I'm so sorry. Like switching the residual soybean oil, the solvent to ethanol, and also decreasing the amount of basic catalyst. In addition to that, the ultrasound device was used for the reaction be proceeded in just 14 minutes. The biodiesel produced were characterized by acid index, thin layer chromatography, and gas chromatography coupled to massive spectrometry. It's possible to predict and evaluate the chemical greenness in the experiment through holistic metric like a green matrix and from describing and is made improvement in the systemic of these experiments. Another holistic metric that has been used is a green stars. In this, the same principle and criteria of the green matrix are considered. However, as it was graphic in nature, it's possible to have a very clean visual comparisons. From what has been said, the best result for the synthesis of biodiesel were with residual oil, ethanol, and 0.75% of basic catalyst, with an average duration 40 minutes and the will to use of the ultrasound bath. Therefore, the performance obtained has 93%. In other conditions, a lower performance was obtained than in the listen conditions. In addition, the critical condition for the use of catalyst was studied, obtaining a low performance when the amount when not necessary. Finally, the use of the ultrasound proved to important reduction the reaction time. In the green matrix, there was a highlight for the principles 6 and 7 with a big change, amalgamate to principle 5, 9, and 12 with pairs and improvements, and difficult with principle 3 because of reactive to explosions. Finally, in the green star, the improvement in the experimental road was good. So there was an improvement in the star filling index from 14% to 65%. That said, biodiesel is clean fuel and an excellent energy alternative, bringing a serial of environment, economic, and a social advantage. The developed green script has a great potential for this clean production, replacing diesel fuel with a biodiesel reduce emission of sulfur, burned hydrocarbons, particulate matter in the nitrogen oxides. The new rotate proposed in this work was objective to be a great alternative to conventional heating and stirring process, production biodiesel with a high conversion rate. Finally, thank you for your attention. This presentation has been funded in the part Beyond the Night. Follow us on social media to stay up to date with news in the world in chemistry, especially in chemistry in Brazil.
Yay, thank you so much, José Victor, for this amazing presentation. I love the slides and I love everything you guys are doing to spread green chemistry. Do we have any questions for José Victor? No, I think I don't remember if I asked you that or not, José Victor, but the ultrasound, you use the ultrasound bath, right, for your reactions?
We use a bath of ultrasound, only this.
Okay, it was not the tip thing. Okay, so we have a question from Eddie. He asks, do you experience any difficulty to separate the product from the glycerol at the end of your reaction?
Yeah. The two products of the process is separated and the glycerin is used in other work. It is biodiesel is work for the make this work.
Awesome, José Victor. Thank you so much. We have another question from Tolga. My question, what is the performance with ultrasound ethanol, 1 hour and a half and 1.5% of potassium hydroxide?
You try to do the procediment with this, how can I say, quantidade?
The quantity, yes.
The quantity, yeah, thank you. We try only this quantity.
Awesome. Thank you so much, José Victor. So his poster is on the chat. If you want to check out his presentation, please feel free to reach out to him. I'm going to share my screen because now it's the time for us to talk, network, and discuss everything that has been said. So now we're going to start our breakout rooms in the back. We'll have a breakout room about toxicology. I'm looking at NIM to check if that's correct. We'll have another breakout room for the GCCSigners in Latin America. So if you have any questions about their research, please go there and talk to them. And also Natalie is going to be talking about grants and opportunities for Beyond Benign. So please, if you want to know more about the DAOs grants and also the 3M grants that NIM talked about in the beginning of the presentation, just go there to talk to Natalie. The breakout room should be open. You might see a pop-up in your screen to go to the breakout room you want to go. But if you cannot see the pop-up, please talk to us and we'll redirect you. We'll take you to the breakout room you want to go. So I'll see you really, really soon.